Hello, good evening. Here we are again to continue our this question and answer section for STPM Chemistry Semester 1. Today we are going to start with a brand new chapter, which is chapter 3, which is about chemical bonding. So hopefully through this video, you'll be able to understand better on how to answer objective questions. So if you like my video, please click like button, and if you feel that you want to receive more and more information in the future, please do subscribe and click the notification buttons for more informations. Okay, so with the station, let's begin our lesson today. So we are going to start from the questions. I hope that you all are ready with the modules already. So here we go. Okay, let's have a look at question number 1. Which of the following molecules has tetrahedral shapes? So you have NH4 plus, you have KrF4, SF4, and SO4 2 minus. Now you have to use the technique of how to draw the Lewis diagram that I shown to you in my YouTube videos. If you want, you might want to locate the chapter 3 videos to find out how do you eventually draw the Lewis structure for all of these. So eventually, after you plan out, you have the shapes for all of these, where we have NH4 plus is a tetrahedral, KrF4 is a square planar, SF4 is a seesaw, and SO4 2 minus is also a tetrahedral. So in here you can see that it is NH4 and SO4 2 minus, which are tetrahedral. So our answer is A. Okay, so this is for number 1. Now, number 2, which of the following could be explained from the viewpoint formation of dative bond only? So, you have when ammonia reacts with hydrochloric acid, a white film is formed. So, when ammonia reacts, so this will have to be the reactions in here. So, wait a second. Okay, so you have the NH3. Okay, so this is how it responds. With the lone pair electron react with HCl. So in here, this ammonia donates a lone pair electron to the hydrogen to form an ammonium white film of the ammonium chloride. So in the ammonium chloride, so you have NH4 plus with a dative bond to the H in here. So you can see that there is a dative bond in here. Then the formations of the CuH2O2 plus is blue, while the CuCl4 minus is green. So in here, CuH2O is Cu, you have H2O6. So this is how you are expecting your complex to look like. Okay. Now for time, okay, never mind. Just finish drawing all of this so that you can see clearly how does the CuH2O6 looks like. Okay. So this is how CuH2O6 looks like. So from here we can see that you make use of the dative bond, and aluminum chloride underforms dimer. So in here you form a dimer via this dative bond, where the lone pair electrons from the chlorines are able to donate the lone pair electrons to aluminum, so that you can form what we so-called as a dimer in here. Yeah. Okay, so this is how Al2Cl6 is formed. Well, CO2 and SO2 are purely covalent bond, where CO2 is a simple covalent molecule, while SiO2 is a giant covalent structure. So in here, from the diagram that I've already drawn for you, 1, 2, 3 are correct. So the answer is C. We continue with number 3. The following molecules undergoes sp hybridization, except, so you have to eventually deduce what the hybridization undergoes by each of these molecules in here. So I just straight away shows you the answer. So CO2 is sp, BCl2 is sp, SO2 is band shape. So if it is band shape, this is how SO2 looks like. Okay, so you have a lone pair electron here. So this is not sp hybridization, this is the sp2 hybridization, and then the CO2, CO. Okay, allow me to draw out all the structure for you so you can see clearly how does the molecules looks like, so that you can imagine why is it that you say that it is sp2, isn't it? Okay, so this is how all these molecules looks like. So in here, the best answer will be C. Okay, number 4, the structure of the amino acid alanine is given below. Which of the following correct angles are correct? Now, in STPM question, usually they will not give you lone pair electrons. You have to know by yourself that whether the lone pair electron exists. So for this NH2, you have 1 lone pair electrons in here. Oxygen, you have 2 lone pair electrons. So in here, since you have 1 lone pair electron and 3 bond pair electron, so you expect to have a trigonal pyramidal. So the angle in here is going to be 107. While this one you have 4 bonding pair electron, no lone pair electron, so this is a tetrahedral. While this one you have 2 lone pair electron and 2 bond pair electron, so you're expected to have a band shape. So in band shape, the angle in here is 104. So the best this is for C, and then this is a 3 bond pair. Okay, no lone pair electron. So in here you shall expect this one is a trigonal planar. So in here, the best answer in here is 120 degrees. So the overall answer in here is D. Okay, so just in case if you want to refer, I'll just still write for you so that you know. Okay. Okay, so this is number 4. And number 5, both sulfur and oxygen are members of group 16. However, the angle of H2O and water and H2S in hydrogen sulfide are 104 and 186.5 respectively. Which statement best explains the difference of the bonding angle between the two compounds? So in here, we are talking about they are from the same group. So why is it that this oxygen has a greater angle compared to sulfur? So in here, because oxygen is more electronegative. Oxygen is more electronegative. So therefore, HOH is pulled closer. So when you're pulled closer, the bonding angle is going to be wider. So that is why it has a smaller, larger angle of repulsion. So with that, the best answer in here is A. Okay. Okay, this is number 5, and then we go to number 6. The angle difference is due. Which of the following simple molecule have dative bond in it? So as you in here, okay. So this is how the Lewis structure for all of the molecules in here looks like. So you have CO, you have SO2, you have CO3 2 minus, and NO. You can see that from here is CO, NO2, and also SO2 have a dative bond in it. So the best answer in here is 1, 2, and 4. Okay. So this is for number 6. Okay, number 7. Which of the following reaction is the bonding angle in the product underlined has a greater than the reactant underlined? So in here you have to slowly one by one deduce what are the angles for all of them. So you have to be patient in this case, where in here we start from H2O. Now, H2O, because it is a band, so it has 104 degree. H3O plus is a trigonal pyramidal, so you have 107, so it is greater. So number 1 is correct. And then in number 2, you have C2H4. C2H4 is trigonal planar, while C2H6 is tetrahedral. So the angle becomes smaller, so which is not in our choice. In number 3, CO3 2 minus is trigonal planar, while CO2 in here is linear. So it's 180 degree. So C, number 3 is our answer. And NH3 here is trigonal pyramidal, while NH4 here is a tetrahedral. So the angle in between NH3 and NH4 is 107 and 109. So it's going to be greater. So it's also one of our choice. So the best answer in here is 1, 3, and 4 correct. Okay. Okay, then this is number 7. Number 8, which of the following pair molecule does have a similar shape? So in order to easily deduce in here, you have to first find out which group does they belongs to inside the periodic table. Now, if you look carefully, AL and B are both from group 13. So this might have a chances to have a similar shape. And this is a 13 and group 15. So in group 15, so you might expect it to have a different shape in here. So BF3 and NH3, similarly, this is group 13 and group 15. While BCl2 is group 2, H2O is group 16. So it's expected to have different. So this is how we can easily tell whether they are expected to have the same shape or not. So the best answer in here is A. Okay, so here is the technique of how you easily tell whether they have bonding angle, same shape or not. Okay. Okay, then we go to number 9. Which molecule of BCl3 is, why is it molecule of BCl3 is trigonal planar, whereas the molecule of PH3 is trigonal pyramidal? So in here, you can see from the structure in here, how does BCl3 looks like. So this is a BCl3. So I'm going to draw out. Okay, well, this is a PH3. So in PH3, you have a lone pair electron at the phosphorus here. Okay, so you can imagine why is it that BCl3 is trigonal planar while BF3 is a trigonal pyramidal. Is it the boron atom has no d orbital, which is wrong. Then the boron atom has BCl3 has 6 electrons in the valence electron, whereas phosphorus has 8, which is correct. Repulsion between the chlorine atom is greater, which is incorrect, and the covalent radius of phosphorus is greater than boron. In fact, actually, this doesn't matter. All the shape is based on the number of the bonding pair electron and also lone pair electrons. Okay, so D has no relevance in it. So the best answer in here is point B. Number 10. Which of the following statement is regarding metallic bond is incorrect? Okay, you're looking for an incorrect answer, so you have to be careful whenever you're choosing your answer. Yeah? A, the metallic bond strengths depend on the size of the atom. Yes, because if you have the same number of delocalized electrons, so the size will become one of the factors that influence it. So A is true. Whereas B, metallic bond can be related to its conductivity of electricity. Yes, so the greater number of delocalized electrons, that means the greater electrical conductivity. Now, this will explain why transition metals has a greater conductivity compared to main group metals. Okay. Okay, number C, most of the metals are solid due to the presence of the metallic bond. So it doesn't really matter whether these metals are solid due to the presence of the metallic bond, because some of the elements, even though they are not metallic bond, they are also solid. For example, carbon, for example, sulfur. So they all have covalent bonds. So metallic bond has no relevance of it. That makes it solid. Another examples of the metals, which is a liquid, which is mercury. So mercury is a metal, but it is a liquid. So you see in here, metallic bond does not give a definite reason why is it that it exists as a solid mostly. Okay, so the best answer in here is C. So this is for number 10. Then we go for number 11. The molecule from the covalent molecule of ABX has the following properties. It is a non-polar. Okay, it has a trigonal planar shape, and then it forms a covalentative bond with ammonia to form a complex of ABX and H3. Which of the statement is not true about ABX and H3? Now you have to try your best to imagine when you say that it is a non-polar. Okay, and the most important is this one. It has a trigonal planar shape. So when you have a trigonal planar shape, okay, so you're expected to have a 3 surrounding molecules in here. Okay. Okay, and which makes this A usually comes from group 13. It can also be from group 14. Group 15 is impossible because group 15 you definitely have a lone pair electrons in it. Okay, okay. So let's have a look together here. So we are looking for not true again, so be careful. A, element A is less electronegative than B. Now this is always correct because usually B in here can be group 17. Okay, it's usually group 17. Yeah? Okay, so the statement that says that element A is less electronegative than B are true. So A is not the answer. B, element B is from group 17 in the periodic table, which is usually true because you only need one more electron to achieve the octet arrangement. So that is why usually it's from group 17. So C, A atoms undergo sp3 hybridization during the formation of B. So since this is a trigonal planar, so it is not going to be sp3, instead it is sp2 hybridization. So C is wrong. And finally, D, AB molecule has an empty p orbital to form the bond. Yes, if you look carefully inside the hybridized states, in the hybridized states of the sp2, okay, usually in sp2, you have empty pz orbital, so that the electron can the bonding pair electron can no, sorry, the lone pair electrons from the ammonia can occupy the empty d orbitals in here. Okay, so this is the reason why the best answer in here is C. Number 12, which of the following explain why sodium is a conductor while chlorine is an insulator? So is it because A is sodium is a metal while chlorine is a non-metal? So that does not explain anything at all, yeah? Okay, so B, valence band of the chlorine is filled with electron. Yes, it does fill with electron, but conductivity not only depends on the valence band, it's more towards a conduction band. So B is not true. And then C, the difference between valence and conduction band of chlorine is small, which is wrong because to become an insulator, one of the reasons why you become an insulator because the gaps of the conduction band and the valence bands are very wide. So C is not true, and the conduction band and valence band in sodium is overlap each other, which is correct. So this is the reason why sodium become the conductor. So the best answer in here is donkey D. Okay. Okay, so this is for number 12. So we goes to number 13. Compound Q and R has the following properties. Both are polar molecules. So now in here, we are going to play elimination game. So which one can be eliminated? So in here, if you look carefully from the selection in here, so all of them in the molecules here of A, B, C, D are polar. So none of them are eliminated. So let's have a look at that second choice. Both have the same type of intermolecular forces, so we have to check one by one. So this is hydrogen bond, this is a hydrogen bond, so A is correct. B, this is a van der Waals forces, this is van der Waals forces, this is correct. So this one also van der Waals forces, this one also van der Waals forces, which is correct. While this one is a hydrogen bond, while this one is a van der Waals forces, so D is already out from our choice. The most important thing is, the last point is, boiling Q is higher than R. So in here, Q must be higher than R. That means HF has a higher boiling point than ammonia, which is correct. HB has a higher boiling point than HBr, also correct. PCl3 has a higher boiling point than BCl3, which is also correct. Okay, so let's see. Oh yeah. This one has a lower boiling point because this one has a greater mass. Sorry for that. Huh? This one has a greater relative molecular mass. So in here, your answer could be A, and your answer could be CA. Sorry, huh? Boiling point of Q is higher than R, so therefore your best answer in here could be A or could be C. Supposedly is lower. Huh? Okay, never mind. Okay, so it's A and C. Yeah? Both answer in here. Okay, so this is for question number 13. Huh? Okay, then we go to number 14. The melting point of 2-hydroxy benzoic acid is 158.6, while 4-hydroxy benzoic acid is 214.5. Which of the following best explain why melting point of 4-hydroxy benzoic acid is higher than 2-hydroxy benzoic acid? So in here, you have to understand inside the 2-hydroxy benzoic acid, there is this what we so-called as intramolecular forces and intramolecular forces. So in here, between the O and H in here, okay, you can form hydrogen bond as a part of this intramolecular forces. So these intramolecular forces will cause less interaction with another molecule. Whereas if today you put another 4-hydroxy benzoic acid inside here, let's say this is the 4-hydroxy benzoic acid. So in between the O and H here, so you make use of the hydrogen bond as the intermolecular forces. So because of these intermolecular forces, they make use of the hydrogen bond, which makes the hydrogen bond become stronger. So that is why the boiling point of the 4-hydroxy benzoic acid is greater than that of the 2-hydroxy benzoic acid. Okay, so the best answer in here is C. Number 15, table below shows enthalpy vaporization between sodium and aluminium. Which statement best explains the difference of the enthalpy vaporization between sodium and aluminium? A, sodium has a greater atomic radius than aluminium, which is not the best to explain, even though this statement is true. B, aluminium can delocalize more electrons than sodium, which is true. Okay, B may be the answer. Let's have a look at the following. Ionization aluminum is higher than sodium, which is true, but it does not explain why is it that the enthalpy change is greater. So I reserve this for a while. And aluminium ion has a higher charge density than sodium. No, charge density has no relevance towards the enthalpy change of vaporization. So the best answer in here could be B. So why B is the best answer? Because if you have a higher boiling point, so you have a greater, if you have greater number of delocalized electron, so you have a greater this metallic bond. Okay. So the best answer in here is point B. Okay, so I didn't highlight, so hope that you can understand. Okay, number 16, which of the following molecules are polar? So in here you have to deduce CH3 is non-polar. I draw out the structure for you. Okay, so this is how CH3 looks like. This is a trigonal planar, so it is non-polar. Well, this is how NH4 plus looks like. Okay, so this is how BrF2 looks like. Okay. And this is how SbCl5 looks like. Lone pair electron. So because of this lone pair electron inside BrF2 and SbCl2, so this will make the molecule to become polar. Therefore, our best answer in here is long PD. Okay, so this is for number 16. Then we go to number 17. Which of the following statements are true for NH3, H2O, and HF? Number 1, NH3, H2O, and HF possess the same type of intermolecular forces, which is true because all of them has hydrogen bond. Number 2, boiling point order increase in order of NH3, H2O, and HF, which is not true. The real order is H2O is supposed to have a higher boiling point than HF. Okay. So number 2 is not correct. Number 3, number of hydrogen bond for all NH3, H2O, and HF are the same, which is wrong. H2O has more hydrogen bond. And polarity of the bond increase from NH to OH to HS, which is correct. Why? Because higher the electronegativity, the more the polarity of the bond. Okay, so the best answer in here is 1 and 4 only. Okay, so this is for number 17. So we go to number 18. Element XYZ may be an electrical conductor, semiconductor, or insulator. For information about the energy bands of XYZ are given below. A. Look at the statement. Conduction band and valence band of Z are overlapped. So when Z are overlapped, so that should make Z a conductor. While the gaps between conduction band of Y is far greater than X, so X is a semicon. So while Y is an insulator. Okay, so you have to find out one by one among the periodic tables in here, which one is a conductor, semiconductor, and insulator. So let's start from X first. Which one can act as a semiconductor? So usually group 14, group 14 are good semiconductors such as silicon or boron, okay, or even germanium. Okay, so in here, this is configuration of silicon, which is correct. This is a configuration of bromine, which is wrong. This is a transition element, also wrong. This is group 17, also wrong. Okay, and then you have Y. Y is a insulator. So insulator are usually non-metal. So example, group 15, 16, 17, and 18. So in here, group 14, this 2s2, 2p2 may be carbon, is for carbon. Carbon may be graphite, may be diamond. So it depends. So we look at the combination later, which one is the best. So this one is a D block element, automatically it's not an insulator. This group 2 is definitely not insulator. While 3s2, 3p4 is silicon, so which is a semiconductor. Okay. And last but not least, Z. Z is a conductor, so it must be a metal. Okay, it might be group 1, group 2, some 13, and some 14. So examples of group 13 that are metal are, for example, aluminium downward, all are metal. Okay, whereas for group 14, it is tin and lead that are metals. Okay, so this is valence electron of lead, which is correct. So this is silicon, which is wrong. This is carbon, which is wrong. Now this is hydrogen, also wrong. So the best answer in here will be A. Okay. So A will fit the description for all of them. Okay, so that is how you solve for question number 18. Then we go for number 19. Pentane C5H12 can exist in different molecular structure. Which of the following is a correct sequence for this compound in ascending order for the van der Waals forces? So in here, this one we have the lowest. This molecule has the lowest. Why? Because it has more branch. So greater the number of branch, lower the total surface area, therefore lower the boiling point. So followed by this one. Okay, this one has a higher boiling point, while a straight chain will have the highest boiling point among all of them, because you have a straight chain molecule. Straight chain molecule will have a greater total surface area and therefore higher boiling point. So the best answer in here will be C. Then we go for question number 20. Boiling point of the methanol, CH3OH, CH3SS are 64.5 and 5.8 respectively. What caused the difference between this boiling point now? Even though both of these now both of these O and S are actually group 16 elements, so they expect to have the same structure. But in here, because you have OH, which can form hydrogen bond very easily, so that is why you can have the higher boiling point. So the best answer in here will be B. Hydrogen bond exists between CH3OH, while CH3SH is weak van der Waals forces. Okay, so this is for number 20. Immediately you go to 21. Compound has either ionic or covalent bond or both. Which of the following statement is not true about ionic bond? We are talking about not true, so please be careful. For ionic bond. Number 1, they involve the transfer of one or more electrons from sp and d orbital, which is correct. Okay, so transfer from s to p, from d to p is possible. B, strength of the ionic bond is proportional to the size of ion. Now, this one is incorrect because we know that the strength of the ionic bond can be measurable by what we so-called as a lattice energy, where we said lattice energy is directly proportional to the charge, yet inversely proportional to the interionic radius. So when we say that inversely proportional, that means if you have a smaller size, you have a greater strength. So the statement B is not correct. So B is not correct. Then we have a look at C. They involve ion with a stable electronic configuration. Usually when you form the electron transfer involved in the formation of a more stable octet configuration. Okay, those not all cases are definitely octet, but ions are trying their best to arrange themselves as stable as they can. So C is considered correct. And D, the result in the formation of a solid compound. So usually ionic compounds are solid. Okay, ionic compounds are usually solid. So the best answer in here is non B. 22. Silicon is a semiconductor. Electrical conductivity can be increased by how? So electrical conductivity of silicon can be increased by either doping with boron, doping with phosphorus, and increasing temperature. Okay, so this is a very direct question. So the best answer in here is A. Then we go to number 23. Which species drawn in the correct shape? Okay, so you have to understand what are the shapes that is represented in here. So this is obviously a linear. Okay, well, this is obviously a square planar. Now, this is obviously a trigonal pyramidal. And PH3 is a trigonal planar. Now, I'm talking about how does the shape in the diagram looks like. But the actual one, I3 minus has a, sorry, I changed the color. So you can let's distinguish the differences. Okay, so I'm going to draw out for you the actual one. So in I3 minus, yes, it is indeed a linear molecule, so which is correct, matching. While SO4 2 minus, the actual one is tetrahedral. Okay, so B is wrong, whereas CBF3 is actually trigonal planar. So which is wrong, whereas pH3 actually have a lone pair electron in here, so it's going to be trigonal pyramidal. Okay, so the best answer in here is A. Yeah? Okay, as for 24, what's the correct sequence of N2, NH2, and N2CH3 according to the ascending order of their NN bond length? Huh? So in here, you have to first look at the structure. So this is the structure of N2H4, whereas this is the structure of N2CH32, whereas this is the structure of N triple bond N. Okay, so we say that if you have a greater number of the bond, okay, so single bond has the longest bond length, followed by a double bond, and then triple bond has the shortest bond length. So that is why in here, the best answer will be B. Okay. So we are looking for ascending in the bond length. So ascending in bond length. So single bond has the highest, greatest log bond length. Okay, so the answer is bond length. Okay, number 25. Which species has coordinated bond in their molecule? So I've already illustrated some of the examples just now. So this is how aluminium chloride, ammonia, and also FeCN6 2 minus looks like. So very obviously is 1, 2, and 3, and the answer is A. Okay, 26. The ionic radii for 4 ions are as follows. Which of the following has the highest covalent characteristic? So in order to understand the covalent characteristic, you have to go according to Fajan's rule. Fajan's rule states that if you want to exhibit a high covalent character, you must have a small cation, a highly or large anion, and also highly charged. Okay, so in here, we are going to slightly use a little bit mathematical things in order to understand. So let's have a look together on which pair we're expected to have a greatest covalency. So in here, you have a greater charge and smaller ions. So you must have Q, okay, and larger ionic radius is R, okay. So the one that have a highest covalent characteristic in here will be Q and R. Right? Highest covalency, sorry. I highlighted the wrong answer, so the best answer is boy. B. Okay. Sorry for this one. Misunderstanding. Okay, so in here, you shall have Q has the smallest, highest charge, smallest radius. Okay. And R has a greater charge and larger radius. Okay, so the best combination is in between Q and R. So the best answer in here is B. Okay, so this is for 26. Then you have 27. The angle of methane, ammonia, and water molecule are shown below. The difference in the bond angle with these three molecules is due to what? If you look carefully inside the diagram here, this one has no lone pair electron, while ammonia has one lone pair electron, while NH4 has two lone pair electrons. So in here we say that lone pair electron repulsion is greater. So that is why it makes the bond pair electron repulsion become smaller. So that's why smaller angle. So in here, the difference of the bonding angle is due to the number of lone pair electrons in the center increase. Yes, which is true. Hybridization of the central atom. So for information, all of these are sp3 hybridized. So hybridizations are the same in this case. So number 2 is not the reason. Number 3, electronegativity of the central atom. So as I explained earlier, electronegativity has nothing to do with the bonding shape and angle. So number 3 is not going to work. And number 4, the number of hydrogen atoms here, which might also influence it because when you have lesser number of hydrogen atoms, so you might expect it to have more lone pair electrons. So the best answer here would be 1, 3. Think about it. Okay, so in here, I'm going to say that there's no answer in here. There's no answer in here. The electronegativity of the central atom does not really influence the bonding angle. In this case, it's not because of the electronegativity. I would say that it's the number of the hydrogen atom. Okay. So the best answer in here is 1 and 4. So I'm so sorry, there is no answer in here. So no answer. Okay. But what am I trying to express to you is, if you want to see why is it that the bond angle for these three are different, so it's due to number one, you have to depend on number of non-pair electron, one-pair electron, and then number two, you have to looking at the factors. The number of hydrogen bond atom, number of hydrogen atom bonded to each element in here, it refers to if you have more hydrogen, then you have more bonding electron. So when you have more bonding electrons, so this will definitely influence their angle. So that is why number 4 is true. So 27, sorry, no answer. Okay, then we move on to number 28. Which are the correct sequence of the compound arranged in order of increasing boiling point? So this one is a little bit complicated because you have to understand by three things, which is non-polar molecule, polar molecule, and even hydrogen bond. So in here for your information, CH3, CH2, we have the lowest boiling point since it has the smallest total surface area because it has more branches. Okay, while CH3, CH2, CH2, CH3 has a higher boiling point since it has a straight chain. So straight chain molecule has a greater total surface area. Whereas CH3, 2CO has a higher boiling point because it is a polar molecule, and CH3, CH2, CH2OH has the highest amount of room since they are held by strong hydrogen bond. Okay, so the best answer in here is A. Number 29, which statement is not true of the formation of metallic bond? So metallic bond is because of the delocalized electron that can move to the whole metal lattice, which is correct. Okay, so the electron can move about in the metal lattice, which is correct. Okay, but we are looking for not true. Okay, so A is not the answer. B, valence orbital of metal atom is superimposed to form a molecular orbital. So in the, even though inside STPM we do not really study about molecular orbital theory, but the facts that the valence orbitals of the metal atom is superimposed is correct. Okay, so metal atoms which are bigger size has a stronger metallic bond, which is wrong. In fact, the one with a smaller size will have a greater this one. So number C is wrong. And then atom is a metal that are arranged closely, which is also correct. So best answer in here is C. Okay, so this is for number 29. Then we go to number 30. Geometry of a species can be deduced from the type of hybridization of the orbital center. Which species has sp hybridization at the center atom? So HCN in here is sp hybridization. SiCl4 is sp3 hybridization. SO3 is sp2 hybridization, and I3 minus is sp3d hybridization. So the best answer in here is A. 31. The 8 species that follow all have covalent bond. In which pair does the species has different shape from another? So you have to deduce one by one what shape. So BCl2 and CO2 are both linear molecule. CH4 and NH4 plus are both tetrahedral molecule. NH3 is a trigonal planar, while BF3 is a trigonal pyramidal. And while the SCl2 is and H2O are both band shaped. So in here, how do we easily tell this one? Okay, so usually, as I told you, one of the factors is you must see they're from the same group. So S and O are from the same group, so they have a very high chance to have the same shape. While in here, if you want to know for details, you have to draw out the structure by using the Lewis, like the way of how to draw the Lewis diagram one by one. Okay, so if you want, I can draw it for you. This is how BeCl2 looks like. Okay, this is how CO2 looks like. And then this is how CH4 looks like. And this is how NH4 plus looks like. Okay, this is how NH3 looks like. NH3 has a lone pair electron. And this is how BF3 looks like. And then this is how SCl2 looks like. And this is how H2O looks like. So you can, so in here, I hope that you can see clearly why is it that they have a different shape. So we are looking for different shapes, so the answer is C. Okay, then we have 32. Histidine is an amino acid. What is the approximate bond for 1, 2, and 3? So you have to understand that number one, this one is a sp2 hybridization. Okay, so with the angle at 120 degree. So and then number two, in ammonia, in amine, you have a lone pair electron in here. So this will make this shape to become trigonal pyramidal. So this is 107. This one has 4 bond pair electrons. So this is a tetrahedral. So tetrahedral is 109. Okay, so the best answer in here will be point B. Okay. Okay, which reaction involve a decrease in bond angle at the carbon atoms? This is a little bit tricky because you have to understand what are the type of reactions. So for SEM 1 student, you have a little bit disadvantages because these are all organic chemistry, most of them. And SEM 3 students have the advantages in this case, okay? Okay, so bromoethane reflux with ethanolic sodium hydroxide. So this is the equation. So you have CH3CH2Br 109.5 to become CH2 120. In B, if you have a combustion of the methane, so you burn carbon dioxide and water. So it's from 109 to 180. So this is for B. And then for C, also dehydration. So dehydration makes the angle become greater. And then finally, from CH2 polymerized, you have a smaller angle. So the best answer in here is donkey D. Okay. Okay, so this is for number 33. Then 34, ethane burn in oxygen to produce carbon dioxide. Which bond angle represent molecule of ethane and particles conducted? So in here, this is ethane. Ethane has 109.5 sp3 hybridized. CO2 is linear, 180, while H2O is a band shape, 104.5. So the best answer in here is C. Okay, last but not least, in which species there is a lone pair electron? So I'm going to show you how does all this structure looks like, and it is clearly obviously that the best answer in here is C. Okay, so there I have for you all the solutions on how to solve the objective questions. Hopes that it makes you understand better on how to solve the objective. So I guess that is all for the sharing for SEM 1 video for today. So if you like my video, please help me to click the like button, and if you want to receive more information, please subscribe. I'll see you all in our next lesson tomorrow. Okay, see you around. Goodbye.